All right, this video is going to show you how to do the second part of the M&M experiment, where we took all those bags of M&Ms and sorted them by color, and we were checking things like how many are in the bag and is there a color that's more common than any other color, and how does that all turn out. So here's where we find the answers, and here's how we're going to do it. And if you need this video, boy, I'm here for you. All right, so first of all, I want to show you that this is really all about doing some calculations, plugging in some formulas and doing some calculations. So that's the biggest part of it. You do have to pretty it up a little bit at the very end, but you can see what I've done here. I took all of your actual numbers that were in your bags of M&Ms from the previous session, and it starts up here with Luke Alexander. These are alphabetical by last name. So it starts up here with Luke, and he's all of his, and then it goes all the way down to Jacob Wilson. And everybody who was present and able to do the M&Ms is on the list. If somebody wasn't there, they're not on the list. But even if you weren't there, you can still do this part of it because you wouldn't have had to be there to do this part. All right. So anyway, I want to show you this. The handout that is posted for you on Google Classroom has all of the answers, people. So there's going to be a whole bunch of formulas that you have to plug in certain places, and then you have to duplicate them. But look for the formulas here. Like this says, look, it tells you what to do. Click in cell H8, you'll be able to find it. And then here's the formula that you put in cell H8 right there. It's right there. Everything is right there. And then you would have to duplicate it down for every row. And then, your next step, click in cell B40. All right, so you go find B40. And you put this formula in cell B40. And then you would duplicate it across. And I'm going to show you that in this movie. I'm going to show you what all that looks like. But I'm just showing you that the handout that is posted on Google Classroom has everything you need to do right on there. All right, but let's go ahead and get to work. Okay, so the first thing we're going to do is this. We're going to we'll start with Luke because he's at the top of the list. I'm going to select all of his M&Ms here from the 9 red ones down to the 7 brown ones. I'll just select all those, and we just want to add them up. Now, this is going to be true on every calculation we make today. Do not do the math yourself. I'm going to be checking to see, did you put the formulas in? That's what I'm looking for. So I am going to come up here to the little sum, the little functions thing, and I'm going to tell it that I want it to add them up, right? I want to do a sum. Now, it might kind of look like the sum is going to go in the wrong place, but don't worry, it won't. It looks a little weird, but it'll work. Press enter. And then I'm going to get the suggested autofill. Well, yeah, sure. Thank you very much. And I'll just hit the check mark there. Boy, that was easy, right? So now I'm looking all down this list and thinking, well, okay, I'm starting to get a picture of, if we said, how many do you usually get in a bag of M&Ms? How many M&Ms do you get? Well, it certainly looks like it's going to be in the 50s. Now, I think Tori snuck along here and has a 61. Look at that. That's actually, I'll tell you this, that's really unusual. That does not happen very often at all. But it did that time. Tori had 61. And, somebody in here, I see a 54. I don't know for sure that is the lowest, but I see several 54s, which appears to be the lowest. Nope. I see sorry, Tinley. Tinley had a 53, only had 53 M&Ms. So that looks like the lowest number that I'm seeing, but we'll figure that out. We'll confirm it here in a minute. All right. Now, if you scroll your sheet on down, you can see all these other things that we're going to calculate. Here where it says color total, what we're going to do is we got a lot of red M&Ms here, right? It starts up here with Luke at the top, and it goes all the way down to Jacob Wilson at the bottom. And so that's a lot of red M&Ms. And this is where you start to see, yeah, boy, I'm glad I don't have to do that in my head. Or I really don't even feel like pulling out a calculator and doing that. So it's nice to be able to know, okay, I can just make the computer do that for me. So we want to add up all the red. So I'm just going to select everything from the 9 down to the 9. It turns out to be another 9, but I'm going from Luke all the way down to Jacob. And I'm going to ask for a sum. That's just going to be add them up. I want the total number of red. Once again, it looks like it's going to put the answer in a really weird place, but it won't. I don't know why it's doing that, but just press enter. Now, be careful here. This suggested autofill is not good. No, no, no. We do not want that to happen. Google Sheets is trying to be helpful, but this time it's wrong. So hit the X. Nope, nope. Do not want that at all. No. What I want to do is I want to take the color total. We had 317 red M&Ms. Now this is where we're going to find out, was there a color that was more common than that? Right? Did we have a color that was more than the red? All right, so I'm going to duplicate that across. Boom. And there it is. Okay. Well, so I'm looking, and you know what? It turns out, no, red was the most. So at least in our 7th hour class, and you know what? I'll tell you, in 1st hour, it was yellow. In 4th hour, it was red. And in 7th hour, it was red. If we combined them all together, I think it would be red. So more red than anything else, but not by a lot. Look, yellow had 307. So there's not a big difference. And then it kind of evens out after that. They kind of drop down a little bit, and all the other colors are floating along here at 250, 240, 288, right? But red had the most and yellow not far behind. So there's the answer to that question. Most common colors in our class, red wins and yellow is second. All right, here's our next calculation that we're going to do. This is we're going to start off just for the red M&Ms. In a bag of M&Ms, on the average, how many red do you get? Well, all right, so that's going to be an averaging formula, but we can't just select all the cells and use this thing up here. That's not going to work. So I'm just going to type it myself. And remember, folks, the handout, remember, right here, click in cell B41 and put in this formula. Man, those are the answers right there. Okay, so I'm going to go equals. And look, it's even, if it does this for you, take it. It's even kind of suggesting, and I think it's right in this case, right? It's got the right thing. It's saying, do you want the average from B8 to B37? And the answer to that's yes. But I'm just going to go ahead and type it because I feel like it. So AVERAGE, Shift 9. And the cells that we're going to use, you have to kind of get used to this. The red M&Ms for Luke are up at B8. And the red M&Ms for Jacob are at B37. So it's going to look like B8 colon B37. Make sure it's a colon. It cannot be a comma or a plus sign or a minus sign or a dash or anything like that. It's got to be a colon. Close the parentheses. Now heads up. I got something to show you. I'm going to press enter. And this does not look right. That doesn't seem right. How could the average be 0.566666? Well, here's what's going on. We have a repeating decimal happening, and you're not seeing the whole thing. And the number is too big to fit in that little box. So we're going to come up here to the toolbar up at the top, and there's a button that looks like a point. It says 0.0 and has a little arrow facing the left. The pop-up says decrease decimal places. Well, all right, so I'm just going to kind of click, 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 click. And now you can see what's happening if you're looking at that number. When I decrease the decimal places, now we're getting a real picture of what it is. It's 10.5667. It's a repeating decimal. And you can take it down to 3 decimal places or 2 decimal places or whatever you want. That's up to you. I think I'll put it at, I don't know, I'll leave it at 3. 3 looks good. All right. So 10.567 is our average number of red M&Ms. Now I'm going to duplicate that across, all the way across. And bingo. There we go. Okay. Now, one of the questions that just got answered, if we said, how many M&Ms do you usually get in a bag? Right there's your answer. 56 point, and if you round it down, right, that would be 56. Turned out the average was the same in period 4. And in period 5, it was maybe I don't remember, it was maybe slightly higher. It might have been 57, maybe, but very close to that. So usually when you buy a bag of M&Ms, you're going to have right around 56. You might have a few more or a few less, but that's about what you're going to get. All right, here's our next calculation, the lowest. Now, so here's what I want the computer to do. And again, I say this so many times. This is not hard to do yourself. You could do it yourself, but I don't want you to do it yourself. I want you to plug in the formula that will do it for you. we're going to look at all those red M&Ms that are listed there all the way up and down, and I want the computer to go look at that set of numbers, all the red M&Ms, and find the smallest number. We're looking for the smallest number. Now, I'm pretty sure it's Kylie had 6, and I think that's it. But let's find out. So here's how that works. I'm going to go equals, and there's a code for this. It's MIN. It means minimum. All right, so I'm going to say equals minimum, and then a left parenthesis, shift 9. And then again, we're going to use that set of red M&Ms, which starts up at B8, and then I'm going to put in the colon, and it goes all the way down to Jacob Wilson's, and that's B37. So I'll go B37, and I'll close the parentheses, and so that's what that formula looks like. It's min equals min, parenthesis, B8 colon B37, close parenthesis, press enter. And 6 was the lowest. Kylie had that. Maybe somebody else did too. I don't know. Yeah, I see Destiny had 6 also. All right, so I'm going to grab the duplication handle and pull it across, and there we go. So it turns out 53. Tinley was the smallest bag, of numbers-wise, it was the smallest bag of M&Ms. All right, now this is a very similar calculation, except it's not going to be the lowest. It's going to be the highest. Oh, okay. Well, so it's going to be equals, and I bet you can guess if you use a little logic. We did min before, M-I-N, minimum. This one's going to be max, M-A-X, maximum, right? So I'm going to tell the computer, I'll do a left parenthesis, and it's going to be that same thing. It's B8 colon B37. I want to start with Luke's M&Ms up at the top and go all the way down to Jacob's red M&Ms at the bottom. So that's B8 all the way down to B37. You got to have that colon in the middle, and I'll press enter. 17 is the highest. I see that Kyler had 17 there, and I don't know if anybody else had 17 red M&Ms. Now I'm going to just duplicate that across, and we do see that right here, I think that's Tori's bag of M&Ms, the 61. She had more M&Ms than anybody else. All right, now the range is just this, and once again, here I go. The math is not hard, but do not do the math yourself. What I want to do is take the highest minus the lowest, and I want to get that difference right in between there. Okay, well, that's not hard math. We know that that's what, 11 right there? But don't type an 11 in here. Don't do it. You'll lose points. Don't do it, don't do it, don't do it. All right, so here's what we're just going to do a subtraction problem. We've done this before. Equals. All right, that's 17 that I'm looking at. The 17 in the highest is at B41. All right, so I'm going to say B41, and then I'm going to subtract B41 minus that 6 that's the lowest for the reds there. That's at B40. So I'll just say B40. All right, so it's a subtraction problem. Look at it. Equals B41 minus B40. We've done this before. This is not new. I'll press enter. Subtraction is made, and I will now duplicate that across. And bingo, got it. All right, well, now look, all the calculations are in. We have calculated, we know the total for every person over here. That's in column H, and it goes all the way down for every person. We know the averages we know the color totals first, how many of each color. And this is a grand total right here, this 1,682. That's all the M&Ms in the whole room yesterday put together. We have our averages. We have our lowest of each color and the lowest bag. We have our highest of each color and the highest bag. And then we have the difference. How much did it vary? And so we now see that the difference in our class was a difference of 8. Highest bag being 61, lowest bag being 53. This is all statistical analysis is what we're doing. We're looking at the numbers and seeing what we can learn. All right. Well, the only thing left is pretty it up a little bit, which you do kind of however you want, right? Give it some kind of fill color if that's what's going to float your boat. And if you want to add borders, and maybe you want to change a font, and maybe I even want to come along here and take all the students' names and align them to the right instead of to the left so they look like that. Whatever. That's up to you. Assignment done.